guys, let's start with the first problem. As you can read the problem statement, we have to create a sampling function. Sampling function is basically a variation of throttle function. Throttling, we have that question in the next, I think we have it here, so we'll be solving that too. Throttling is basically of two types. One is time or duration based, and second is invocation or count based. So in duration based, what happens is, let's say if you have implemented the throttle, the function which has been passed to that throttle will be invoked once in the specified duration. Let's say I wanted to invoke once every 1 second or 2 seconds. Here it functions similarly, but it will invoke on the count. For example, if I invoke this sample function, this callback will be invoked on the count or the ith count. So on every fourth count. So here it is being invoked. Again, here it is being invoked. So that's how this sampling function works. It's basically a version of throttle, but it works on the count rather than the duration. So let's start implementing this. Let me copy everything from here. And paste it inside this. This is a Node.js environment, as you can see. So we are going to code in the Node.js environment. Node.js environment is little bit different from the browser environment in respect to what all objects that we have access to. But for this function, it should suffice that we should be able to code this in the Node.js environment itself. We got the message, we got the sampler. Let's implement the sampler function. So here I'm going to create the sampler. So const sampler. This will take a function which will be invoked and the count. And as you can see, this sampler functions, it takes the function as input which will be invoked and the count, and it returns another function. So whatever it is returning in the variable sample, we are invoking it as a function, which means it is returning another function. So let's create here another function. So return a function, will be returning a function. And now we have to invoke this function on the past count. So I'm maintaining a counter here or a tracker to trace like how many times the return function has been invoked. So here on the every invocation, I'll increment its value. So just counter plus plus, this will increment it. Now we have to invoke this input function when the counter value is equals to count. So we are starting from 0. On the first count it will become 1, on the second count it will become 2, on the third count it will become 3, and the fourth count it will become 4. So what I'm going to do is I'm going to add a base condition here. Base condition is basically we are going to use pre-increment operator. Plus plus counter is not equals to count, then return. This is the base condition which will terminate if the counter value is not equals to count. The pre-increment operator, this will return the value and then increment it. So this check, this will return or terminate the function here itself when we are calling it for the first 3 times. On the 4th time it will be invoked. So on the 4th time what we have to do is we have to invoke the function, and then we have to reset the counter to 0 so that it can start executing again. Now let me run this. We have 1 2 3 4 and 4 8. So 2 logs of hello should be printed, because this function on every 4th count it should be invoking the input function. Now if I run this code, it is throwing error because this is a fat arrow function and we had forgot that. No worries, let me run this. Sample has already been sampler. So we got hello on the to count. Let's say if I update this and I want it to be invoked on every first count itself, then it should have 8 hello logs. So if I run this, we should get 8 hello logs, which is 1, 2, 3, 4. Yeah, so it is working fine. If I do it on every second count, then we should have 4 hello logs. So we are getting 4 hello logs because this is invoking on every second count. So our throttle implementation is in place. This is how you have to solve this function. Here we have made use of closure. Closure is basically a return function from a function has access to the parent function's variables, arguments. So as you can see, even if I have written this function, it can still have access to the counter, the function and the count, and it can update those values. So we have formed a closure over here of this return function with its parent, and that's how we have solved this or implemented the sampler function. Majority of problems involve a combination of closure async operations that we'll see going forward, but this is how you can implement the sampler function. I'll see you in the next problem. Thank you.